Welcome 7th graders to lesson 9.2. I can evaluate functions and I can state the domain and range of a function. So here we are on page 469 of our textbooks. Remember, evaluate is kind of another word for solve. So we will be like solving for. We'll have operation, then we'll have to get an answer. And we'll learn about some vocab words, domain and range. Functions. 9.2 functions. Functions shows a relationship that assigns exactly one output value for each input value. Output, input. If you remember, we used to coordinate that we plug in an x value, usually in an equation, and we get out a y value, usually. Today, now, instead of x, though, we're going to have this thing, or y, instead, we're going to use this thing called f of x. Sometimes you guys have seen something like this, where you have a y value, a number, and an x value. We're going to be replacing that y value with f of x. It is read f of x. It really means the function of x. So we can say the function of x is, remember, equals is 15x, or we can just say the f of x is 15 times x. Okay, so an x can be any real number that you plug in. This is your input. This is your output. So if we want to find the value of a function for a certain number, we can substitute that number in for x, again, our input. So we're going to go ahead and get started on some of these. Not much of this is really that new to you. You've done a lot of this before. So if we're saying we want to know the function when x is 9, so the function of x is x minus 9. So what we do is we plug in, we replace. So we're going to go with a function when x is 9 is 9 minus 5. We rewrite everything down. The function when x is 9 would be 4. And that's our answer. Same thing here. We're going to plug in negative 3 for x. So we do the function when x is negative 3. If the function is 2x, in this case negative 3, plus 1. Order of operations tells me to do multiplication first. So I say the function when x is negative 3. 2 times a negative 3, positive times a negative is a negative 6 plus 1, leaving us with the function when x is negative 3 to be negative 5. It's really that easy. So you could pause here, check, pause, and then come back and check the answers for these two examples. And they're also in your textbook. I would suggest pausing and coming back. So I'm going to plug in 2 for x. Oopsie. That was a mistake on my end. So I'm going to plug in 2 for x. That's a common mistake that some of you make, is you put it next to it, but you're actually replacing it. So that's 2 minus 4. So the function in this scenario, when x is 2, is going to be negative 2. On the right, we're going to replace 6. So the function of x, when x is 6, 2 times 6 instead of x then, minus 8. So we do the function when x is 6, 2 times 6 is 12, then minus 8. So the function when x is 6 is 4. Hopefully that's not too bad for you. So, some keywords, and this is starting on page 470, I believe, in this include domain and range. The domain is your input values, and those are your x values. The range, the output values, sometimes you see them as y, and in this case today we're going to see them as f of x, what we get out for the function when we plug in x. So remember the variable, and there's a little study tip for you. Input output, the variable for the input is called the independent variable because it can be any number. The variable for the output is called dependent because it depends on the input. We've talked about this before, independent and dependent. Independent is, you're the one changing things. So if we plug in, we can plug in anything we want. We're pretty independent. Whereas what we get out depends on what we plugged in. So hopefully those are a little bit explanatory, and we'll talk about those a little bit more in class as well. You'll hear that a lot. So we're going to make a table. So hopefully right now either pause and make something that looks like this on the right, or print some out from Google or something like that. So make a function table. What we're going to do is we're going to complete the function table for the rule the function of x is x plus 5. Then we're going to state the domain and range because we're good direction readers. So what we do to fill in the chart is we substitute each value of x in this column, the input, into the rule here, and then we simplify to get our output. For example, we do plug in here, x is -2, so we do -2 plus 5. So what we get out is the function when x is -2 is 3, and so on. -1 plus 5, so the function when x is -1 is 4. 0 plus 5, the function when x is 0 is 5, and when x is 1, the function comes out to 6. So our domain then, we put them in these little special bracket things, okay? We list them with commas and in our brackets. So domain is -2, -1, 0, 1. Those are our input values. Our range, our output values are 3, 4, 5, and 6 for this specific rule. So a little bit more of an example. So you can do here, copy and complete each function table, then state the domain and range of the function. So same type of deal, I would pause and create this, and then you can fill in and check your answers with me. So you just replace x, and you get out y or f of x. So we do -3 minus 7. Hopefully you remember your chop minus rules, and you get out a -10. -2 minus 7, add the opposite rules for -9. -1 minus 7, add the opposite rules for a -8. And 0 minus 7, which is -7. And so we list our domain and range. So I do my domain. Don't forget your squiggle brackets. That's not very good with this iPad pen. Are -3, -2, -1, 0, my input values. My range values are -10, -9, -8, -7. What I got out after I plugged in. Same thing over here then. 4 times our x of -5, input, input, output. And we end up out. Positive times the negative is a negative. 4 times -3, we get out a -12. 4 times that +2, get out a +8. 4 times that +5, we get out a +20. For a domain set of -5, -3 to 5, which yields an output, a range of -20, -12, 8, and 20. The last one, notice it's a multi-step, okay? So it's multiple steps. So in that one, we have to be a little bit more careful. To do 2 times -1 plus 3, we have to do this portion first, which 2 times -1 is a -2. -2 plus 3 is 1. We do 2 times 2 plus 3. 2 times 2 is 4 plus 3 is 7. I'm just writing over it so you can see what I'm doing. You could probably just leave yours and make sure it's nice and neat and use the calculator. 2 times 3 plus 3. We know 2 times 3 is 6. 6 plus 3 is 9. 2 times 5 is 10. Plus 3 is 13. So then we do our domain with our set of -1, 2, 3, and 5 is what we plugged in. And our range, what we got out was 1, 7, 9, and 13. All right, sometimes functions are written with two variables, like we just saw in that last table. Okay? Well, it wasn't really last, that was two-step. One variable usually is x, represented the input, and the other, y, represents the output. Like I said, we could have written, instead of f of x equals x plus 5, we could have written y equals. Kind of interchangeable here, so don't let that get too confusing for you. We're going to look at a real-world example. How a veterinarian technician uses math to administer medicine and vaccines based on body weight of an animal. So, functions with two variables. A veterinarian technician needs to administer medication to a dog. The dosage is 5 milligrams of medication for every 1 pound of weight. Write a function to represent the amount of medication needed for p pounds of weight. So you have an input. Obviously, the medication is going to change based on the weight of the dog. You're not going to give the same medication to your Labrador as you are to your little mini pug, okay? So that has to take into account. So then determine the amount if a dog weighs 33 pounds. So this is if your input is this after we find out. So what this means is the amount of medication, M, is 5 times the weight of the dog. So that can be represented as medication is 5 times the pounds. If you need 33 pounds is our input P, so we plug in 5 times 33, ended up at 165. What this means then is the technician would give a dog 165 milligrams of medication at 33 pounds of weight. Here's another one for you to try, and then maybe we can visit it in class, see how you do. An air conditioner repair service charges $60 for a service call plus $30 per hour for labor. Write a function to determine the charge C for the service call with H hours of labor. Then after you write an equation or a function, how much would you charge for 3 hours? So pause and give it a try. I will just do it in here then. So we have to find our important information. Air conditioner charges $60 for a service call plus $30 per hour. When it says how much would be charged, that's what you're looking for. C represents charge, H is hours. So obviously the input is the hours that it takes. The charge is what you end up paying. So you think the charge depends on how much you pay. So you even think my charge is, the thing that's changing the variable H is 30. Repeatedly adding 30 for every hour it counts, and then plus 60. It's going to be our function. So if it takes 3 hours, we do C is equal to 30 times 3 plus 60. So the charge is going to be $90 for the hours plus 60 just for the call. So it is going to cost $150. Don't forget, for better understanding, you may rewatch the video, read examples in the book, personal tutor, Miss Ha, Mr. Lentz, all of those goodies. Good luck. We'll see you soon.